Science!
Okay, D-Man, on Science this week, real quick, what I want to do is I want to touch base on a topic we've been talking about the last couple weeks, and that is the New Horizons spacecraft and the asteroid in the Kuiper Belt, Ultima Thule. And we talked about how it made
Coolest
it there.
name, too, by the way.
It made it there to orbit this far distant celestial body on January 1st. And what's really cool is they compiled all of the photos that they got of Ultima Thule as the spacecraft, the New Horizons spacecraft, was approaching it. And they have this approach video that I'm going to play for you guys. It's real quick. It just shows, it gives you that sense of approaching this thing, which is really, really neat.
Like, this is what it's like when Ultima Thule crashes into your face.
And like I said, it had this close encounter on January 1st, and it's about 2,200 miles away right now, and it's orbiting it. The spacecraft downloaded these high-resolution images and sent them back 4 billion miles on its way back to Earth.
Wow.
Yeah, and it's still going to be out there for months.
It looks molecular, doesn't it?
Yeah, it really does. Well, and like we explained on an earlier episode, it's really showing us how a planet was formed 4.5 billion years ago. That's how old this thing is. It never turned into a planet. It was just the beginnings of it.
Yeah.
And we kind of saw that from there. But I just thought it was neat that they compiled it into that little animation to just give you that insight of approaching it just like New Horizons did. Another cool thing that happened from space just recently is there was a photo of Earth that was taken 71 billion miles away. NASA released this brand new photo of our planet from an astonishing 71 miles away, and that is from the OSIRIS-REx mission. And we talked about that recently, too, where that is it's near this asteroid called Bennu, and it's going to be orbiting that asteroid, and in a year or so, it's actually going to just kiss it and take a sample from it, and it's going to come back to Earth in 2023.
Crazy.
Which is and we're going to be able to really, see that kind of thing. And again, if you guys are just listening to this on our podcast, you can go over to Fueled by Deathcast on Facebook and see all these photos that we're talking about right on our Facebook page. But this photo of Earth from 71 million miles away. Sometimes the millions and billions get a little weird.
Out in space, what is, and I've heard this talked about a lot, in our minds, what is the relative distance between 71 million and 71 billion
exactly.
miles? Literally, my brain goes, a fucking lot.
Right.
It's just a lot.
So if you're looking at this photo up in the top right corner there, that is the overexposed image of the asteroid Bennu. Now, all the way in the lower left, you can see a tiny pale dot with the tiniest dot next to it. That is the Earth with our moon.
Oh, that's the moon.
And that is 71 million miles away.
That's so cute.
That's really, really cool. Now, this harkens back to one of the most famous photos ever taken and the farthest away photo ever taken, and that is the photo called the Pale Blue Dot. The Pale Blue Dot was taken from Voyager 1 as it was past Pluto, and Carl Sagan asked for it to turn around and point itself back towards Earth so it could take that photo, and that tiny dot in the red line is 1 pixel in width, and that is the Earth from the farthest away we've ever done it. And I have a really short and very cool video remembering the Pale Blue Dot photo from Carl Sagan's actual wife, Andrew Rinn, and here's that.
This was the pale blue dot. This was our willingness to see the Earth as a 1 pixel object in a far greater cosmos. It's that humility that science gives us, that weans us from our childhood need to be the center of things. And Voyager gave us that image of the Earth that is so heart-tugging, because you can't look at that image and not think of how fragile our world is, how much we have in common with everyone with whom we share it, our relationship, our relatedness to everyone on this tiny pixel.
Yeah, it's some heavy stuff.
It's
really
touching,
cool.
man, yeah.
Yeah, I mean, it really does put it into perspective when you think about the world and how large the Earth is when we're sitting here on it, but then seeing it represented as a single pixel in a picture. You know, it's like we're all on that tiny pixel.
I mean, it's literally just a speck of fucking dust blowing in space wind.
Yeah. Yeah, it's pretty crazy. And that's why I wanted to bring up those two things real quick at the top of our science segment this week. I thought that was some pretty cool stuff. But the story that hit this week, actually, I think it was last week or the week before, I read it in one of the science journals. I thought it was really, really interesting. We are observing now that white dwarfs are turning into crystals. And that's really cool when you think about it. So, white dwarfs are the remains of medium-sized stars similar to our sun. Once these stars have burnt all the nuclear fuel in their core, they shed their outer layers, leaving behind this hot core, and then over millions and billions of years, that cools down and cools down and cools down. These ultra-dense remnants still emit thermal radiation as they cool, and they're visible to astronomers as rather faint objects. It's estimated that up to 97% of the stars in our Milky Way galaxy will eventually turn into white dwarfs, while the most massive of stars will end up as either neutron stars or black holes.
That's so weird.
Yeah. So
I still don't understand how any of this works.
well, the cooling of white dwarfs lasts billions of years, like I said. Once they reach a certain temperature, the originally hot matter inside the star's core starts to crystallize, becoming solid, the same way that crystals form on Earth. And the process actually is very similar to liquid water turning into ice at 0 degrees Celsius on Earth, except that the temperature at which this solidification happens in white dwarfs is extremely high. Think 10 million degrees Celsius.
wow.
Yeah. Now,
I
this
can't think 10 million. That's like saying 71 million miles away. It's
It
just-
is.
I really have no sense of relativity of that.
Now, this is an artist's impression of some possible evolutionary pathways for stars of different initial masses. Some protostars, brown dwarfs, they never actually get hot enough to ignite into fully fledged stars and just simply cool off and fade away. Red dwarfs, the most common type of star, keep burning until they've transformed all their hydrogen into helium, turning into white dwarfs. Sun-like stars, like our sun, swell into red giants before puffing away their outer shells into colorful nebula while their cores collapse again into a white dwarf. The most massive stars collapse abruptly once they have burned out, and that leads to a supernova explosion, a gamma ray burst, and, like I said, leaving behind either a neutron star or a black hole.
It's kind of a cool graph, but it's
Yeah.
like it's just wild to think about these things.
It really
like,
is.
what is happening out there, and why is this happening?
Exactly. So not all white dwarfs crystallize at the same pace. More massive stars cool down more rapidly and will reach the temperature at which crystallization happens in about 1 billion years. White dwarfs with lower masses, closer to the expected end stage of the sun, cool in a slower fashion, requiring up to about 6 billion years. So our sun still has about, as so scientists say, about 5 billion years before it dies. Okay?
Before it goes into this
becomes a white dwarf. Before it burns out its core.
How long before it becomes the red giant?
It is a red. Our sun-like star will burn into a red giant gradually through time. Okay, and then it will shed all those layers off and become a white dwarf in about 5 billion years.
I mean, I'm sure before it even becomes a white dwarf, we'll be wiped away.
Of course, and then
And not just because of time, because of the process of
Right.
it turning into a white
of course,
dwarf.
and then once it's a white dwarf, it's another almost 5 billion years, maybe 6 billion years before it crystallizes.
Oh, that's so strange. So there's literally giant crystals flying around in space.
That's what's the coolest thing about this. So Dr. Tremblay says
Wow.
all white dwarfs will crystallize at some point in their evolution, although more massive white dwarfs go through the process sooner. This means that billions of white dwarfs in our galaxy have already completed the process and are essentially crystal spheres in the sky. Now, what's amazing about this is that this is Star Trek type stuff or Star Wars type stuff, science fiction type stuff, where you see the intrepid gang of whatever in a starship, traveling the cosmos, and they come across this planet that's made out of crystal. Like, it's one of those crazy things that you'd see like in a Star Trek episode or something, but it's real.
It's real.
It's real. What could we do with that crystal? Who knows? How hard it is. It could be the hardest thing in the universe.
Yeah, it could be a billion times harder than a diamond.
It could be the most powerful fuel we'd ever thought of.
So I wonder what the gravitational pull on these giant sphere-like crystals are.
I think next to nothing because it's lost all of its radiation.
Yeah, but it has a lot of mass.
It's true. It's true.
Does it have a significant amount of mass because it's so dense? Like if that were a giant diamond, it'd have a seriously amount of mass.
We're just learning all these answers to these questions because this is something we've theorized about white dwarfs. We've theorized that, hey, we think that this is happening. Now with the technology that we have with like Hubble telescope and like the ways that we can look and peer into the depths of the universe, we're seeing, this is really what's happening. We're seeing this happen. We're seeing stars burn out all of their stuff and apparently be this hard crystallized mass. But we're starting to figure out, okay, what does that weigh? What is it comprised of? What can we learn?
Have we even found one?
We have found the remnants of what we believe that this is happening, but we haven't found a specific one to study because they're so far away. There's universe is massive and there's so many stars. And when you think about it,
but now that we know it exists, we can kind of look for it.
That's the thing. Now that we know what we're looking for, we can specifically make instrumentation to look for this.
Yeah.
The same way, like we've talked about on previous science episodes, that we're starting to do just scanning our skies. Again, last week we talked about exoplanets.
Yeah.
Just 10 years ago, that was a pipe dream. Like, man, I hope Hubble could find something if we pointed over here. Now we have specific instruments like the TESS spacecraft in space specifically looking for these things.
Yeah, and we're building better machines every day to handle this.
Exactly. So it would just go to show that I would be very certain that in the future we will have specific instruments in place that are looking specifically for crystallized white dwarfs.
Oh, can you imagine? Well, y'all know when we do find one, you're going to hear it first. For sure.
For sure.
We're going to be stupid excited.
I'm already excited because just giant balls of crystals floating around space. That's some pretty fun things to think about.
Yeah, and I mean, wait, let me go back a little bit here.
All right.
So 97% of the stars in our Milky Way Galaxy will eventually turn into white dwarfs. That means there is a distant future. Billions and billions of years where the Milky Way will be specifically comprised of 97% of spherical crystals the size of planets and stars just floating around.
Well, and you have to, here's to get it.
And you think, sorry, there could be ghost galaxies out there that are specifically just that, almost like a ghost town where just like there used to be life here, but it's all just giant floating spherical crystals.
And I'll break your brain a little bit farther. Because we've been talking about distance and time and the way light reaches us and how long it takes, a lot of what we're seeing could already be galaxies of crystals, and we're just seeing the death of them.
We're just seeing its past.
Right.
Okay.
Stuff.
Yeah, that's
Crazy
a good one.
Stuff, but
good
I like
one, Jeff.
It.
Good
but
find.
I like it a lot.
Yeah.